Kim, you may start.
All right. Well, a lot of good questions. Actually, a couple of them I have written down.
Yeah.
So those are crossed off. Very good. I read the literature review, and there are a couple of alternative methods are discussed, right?
Mm-hmm.
Including the IC baseline,
Mm-hmm.
but let me just put that there. You mentioned that a couple of disadvantages. Well, you say a disadvantage of both, and again a disadvantage of whatever has the other upper hand.
Mm-hmm.
So in the end, I think the one that seems to be best is that the factor model, right?
Yes.
With the least number of disadvantages.
Yes.
But you chose the one with the most disadvantages as your baseline.
Yeah.
What is
So obviously IC is a bit more simple to implement, and also I sort of combined it a bit because the one of the disadvantages was that you couldn't incorporate all these different variables, and so rather than to go straight to the factor model, because that has a lot to do with that you can also go from for example monthly variable indicators to produce quarterly forecasts, but I did take the factor part, so by applying PCA to create these components or factors, so that you could incorporate a lot more variables. So rather than and to use the factor model straightforwardly like they do, I decided to take the factor part, but then add that to IC to keep it a bit more simple. And a natural extension would also be to see, because with this you could also say, well, after the first month, because that's what all the bridge models are and the factor models also, after the first month we have a month of news articles, produce a quarterly forecast, that then gets updated after a second month and a third. So we could also maybe produce forecasts earlier that are reasonably accurate, and that just get better and better as it's updated.
already during the time period.
Yeah, so that's what the bridge models are for, that after the first month you have some economic indicators, so we can already produce a first quarterly forecast and then update it as more data gets available. So that could also be extended to this, obviously, because each day you get new news articles that you can straight away feed to the model and update your forecast.
Yeah, so now you basically need the quarter to be finished.
Yes.
So you can start, right?
Yeah.
Okay.
Yeah.
The table you showed was a bit larger with the results. So
Mhm.
just finding that. It was a bit larger than it was in the thesis, I think.
It should be the same one as the
I
last
think
one.
the original IC was not in the table here, but I think you added the IC
Oh,
just
that's-
RS.
That's
or-
weird,
or-
because
or
I
have
copied it.
Okay,
I don't know, maybe
then I
something
might
with the
have,
versions went wrong. Yeah.
yeah, probably. Well, anyway, that's not too important.
Mhm.
I was wondering if you can explain why going from static to dynamic seems to be most helpful for the baseline and less helpful for the more advanced models. Neural networks only, barely.
Yeah, they pretty much stay the same. The random forest was a bit. I guess theoretically it should improve for whatever model you have. But I think what we're dealing with, at least with IC, is that doing the dynamic, it sort of starts overfitting. And so by readjusting all these coefficients, it's better when you have the static, because then you have once the coefficients and you apply it to 6 years. So I think it's a sort of an overfit that by readjusting them, you somehow go the coefficients fit the training data too well, that you sort of get these shootouts. But yeah, that's speculations, and it's hard to say exactly why that is. And it could also be, obviously the random forest and neural networks, they are much more complex and have a lot more parameters that they update at each step. So it could be that because they have a lot more, you see the improvement a bit more, because there's so many variables they use that gets updated so that it does help. While with IC it's only 2 or 3.
Right, but
coefficients.
so the IC plus the sentiment variables is actually worse in dynamic, but if you have just the original IC,
Yeah.
I think that one
That gets
improves,
better.
right?
Yeah. And I think it's because I used the PCA components, and I think it was I had one or two that actually stayed in the model after a significance test. So I think what happens is you only have the one. Well, let's say we have one component or two, but you have very few. So a change in the coefficients obviously has a big result in the forecast, while for example the random forest and the neural network, a lot more of these components were included. So one weight that was maybe estimated wouldn't have that big of a result in the forecast. So I think that's why I see maybe, yeah, if it misestimates the coefficient, it suddenly gets this outlier forecast, so to speak.
Right, and that gets fixed with the dynamic. Okay, thanks.
Yeah, may I ask a very sort of overall type question to thinking? Like you started out with saying, well, can we use sentiment variables to improve? So would you, if I want an estimate for GDP, what should I use? Your model? And which one?
Well, for Dutch GDP, as of now, yes. Yeah.
And which one?
The neural network.
The neural nets.
Yeah.
So you would really say that you go for if you want to, if I want a prediction now, I should use your neural network.
Yeah.
And but okay, why not a factor model?
Well, from the research I did, they haven't been successfully applied yet to Dutch GDP, but I did a comparison with you have a lot of CPB does predictions, DNB, etc. At least ICE did a big performance overview, and they were all actually worse than the IC plus expert opinions.
Worse.
So yes, so obviously, at least in this performance overview by Philip Francis. So by extension, if we do better than that, we should do better than all of them.
Okay. And then, okay, but if I do a prediction, so this your data run from when to when?
2000, the first quarter to the last quarter of 2015.
15. So already you could update.
Yes.
And so if we want to predict, we're predicting for the next quarter. Already?
No, the recently ended quarter, so we could predict the fourth quarter of 2016.
Yeah, that's what you did.
Yeah.
But if I want it now, then we want to re-estimate it.
If you want for this quarter,
the
the current quarter. Well, I do think you would then have to change it because obviously now we're say halfway through the quarter.
That's right. Yeah.
So there's not as many news articles as the full quarter, obviously.
Okay, so
I guess you could say, well, these are the sentiment scores for the whole quarter, well, it's only half, and see if it works, but I can't.
No. Okay, but let's so we wait till the quarter is finished. But okay, say I want to do that. So you say that this is the best way to do it, and I also have to do the neural network. Yeah, you recommend that. So how easy would it be for me to do this?
Well, so if you keep track of all the news articles that are published, and you parse these throughout the quarter as each days go, then you basically have that work done. So you have all these parsed sentences, and then it's only a question of generating the variables.
Yeah.
If you use the restrictions that were found optimal so far, obviously you could also re-estimate or optimize the path restrictions, but I don't think that's necessary for one quarter. But then it's just a matter of generating the variables and using it in your model. So then, yeah, say an hour after the quarter ended, you could have your forecast.
Yeah?
Yeah.
But that is assuming that I am only a Volkskrant.
Yes. But it should apply also to other newspapers, because then you just parse those sentences, so that shouldn't matter. But then I guess you need to collect from 2000 to optimize these path restrictions, because they could be different for example, NRC or Financial Dagblad.
Yeah.
So you would have to re-optimize those, but once you have that, then it's the same story. If you keep track of the new articles each day and parse the sentences, so you have that stored, then it's just a matter of generating variables and
fitting the neural net.
And fitting the neural net.
So So, but and all in all, how complicated? Because I would say, so there's a trade-off. I mean, what you're doing is it's a lot of work. You had like these numbers before, how many things, how many opinions and stuff.
Yeah.
So there's a lot of stuff, and more coming,
Yes.
And then actually what we didn't see here, and but what is of course an issue with these neural networks, is that you have to make some choices to fit it. You had some, actually I'm very surprised that suddenly works the best. Because your data set is relatively small.
Yeah.
In the observations. So there's a huge chance of overfitting, and also you mentioned this somewhere that well, you have to basically randomly start somewhere.
Yeah.
It's very sensitive to that.
Yeah, you had some random starting weights. But the way I've solved it was by using a small validation set, and then using, well, I did 100, but you could obviously do more random or neural networks, so each have different starting weights that are then fitted to, well, minus the validation sample and see how they perform. And then I used the best performing starting weights on the next to do actual forecasting, because then they are already, well, reasonably good starting weights, and then you can use those for forecasting. And I, well, would say I was lucky because it is a small sample, but in my case actually the validation sample that I used, so 2008 and 9, was quite representative for 2010 to 15, because I did some experiments on that, and whatever you chose based on validation would be the same if you did it out of sample.
But okay, that's a lot of stuff you already say. So if I redo it, then do I have to redo everything again? Do I have to run this process the same? How many?
Well, after
you said I have it finished in an hour. Really? Is it like this?
Well, if you don't want to optimize all the path restrictions, again, so in our case we did that on this sample. So if we would say the first quarter of 2016, I wouldn't say, well, you have to re-optimize all that. Then it's just basically fitting your neural network which is with 100 starts in the validation sample. But if you have that script, it goes fast, obviously. And so that's why if you keep parsing all those sentences, so you have all your data variable, then it is quite efficient if you have it already programmed, obviously. Yeah, and at the point that you need to re-optimize all your path restrictions, then it takes a couple of days. But
you have, as data in there, you have aspects. They also change, or not? They may change with new articles.
So that's also something you could do, because the Google top search queries are obviously now. And I use those as if they were always the top search queries. So what you could also do is obviously continuously seeing if new search queries are the top search query, and either adding them or replacing the original ones, so we actually get new aspects.
But if you get new aspects, then the measurements of the new aspects on the previous things, how do you do that? Or they are zero there? Or maybe they weren't there but they weren't. I don't know. Is this also obvious? Because you add basically a column to your data matrix with an aspect.
Yes.
I can see that if this is the result of the newspaper articles now, so you use your formula for relative positivity, that's okay. But I don't know, could it be that the aspect also, like before you didn't use it? But you say you use the most popular terms or something.
The top search
you
queries.
fixed some aspects already.
Yeah, so in this case, that were the top search queries, but that was then when I did this.
Yeah.
So a couple of months ago.
So if you do it now, you have a different top search?
Yes,
so
probably.
You get maybe new aspects?
Yes.
But
and so ideally we would want to know from 2000 on what were the top search queries. So you could create a rolling or continuously you get new aspects that are added. But well, you can't do that backwardsly, but now you could update the aspects. Yes.
But if you update them, so now you get new words, but these words also before, I mean, you could find a score for that, not? So the previous data, you didn't include that, so you can calculate this relative positivity thing.
Yeah.
Only on those based on your search results, the list you just mentioned. So if I have a new list, a new aspect.
Yeah. Then you would have to redo it from
everything.
Yes.
Yeah.
But you could, well, at least if the aspects don't change too much, you could make an argument that you don't need to do this path optimization again, because that is the most time consuming, because you have all the data. So going backwards again, if you have a new aspect that weren't previously there, yeah, then there's some sentences that hasn't been parsed or converted to opinion set, so that would have to be done. But if you then apply the same path restrictions, then again, it's not that time consuming. You would be done within a day. And it's only at the point that you really want to optimize the path restrictions again that we're talking in 3, 4, or at least days rather than a day.
What was the effect of that actually? The path.
Well, so that's the way. So I sort of on purpose said, right, every combination of this aspect with sentiment word will classify that as an opinion, which is obviously wrong, as we saw with that one sentence. And sort of did that on purpose, that we have, well, too much, and that we then rather discard opinions that we, well, are incorrect, or at least we consider incorrect, in this case, not useful for predicting GDP. And so the way we do that is with the path restrictions, so that we can say, well, any opinion with a path that contains blah blah blah.
So you did a huge
discard
tuning on everything on this path. I remember all of this stuff, but
Yeah.
I forgot like what was the gain of that. So you have the best one.
Yeah, so then
the optimal
you
one.
have.
If you compare that to the worst one or to a
Oh, that way. Yeah.
If I don't do it, like if I just I don't know use a very naive approach
Without any restriction.
maybe
I
I don't know.
Yeah, now I have to think by head. I do remember at least the length restriction, it went down quite a bit, or the performance went up quite a bit. And also on these, it was more if you restricted the wrong path restriction. So let's say we restricted, you had a modifier relationship.
Yeah.
If we said, well, any opinion that has that we discarded, then the results got really bad, and you really need that. And then you had the ones that we did restrict. If you allow them, it did get a bit, obviously, worse performance, but it wasn't too bad actually.
Do you know which ones you kept?
Yeah,
results?
the subject, modifier, predicate actually I didn't keep, which surprised me, or intuitively. So subject, modifier,
I mean, here they are. Something like that.
conjunction, yeah, so anything.
Anything where the first is bigger than the second.
Yeah, so modifier, subject, object, object 2 not, DPS, VCS, and conjunction, yes.
And the length.
And here we see, and the length we kept, I believe the final one was 10, that's here. I believe 10 was in the end the best one, in combination with
Because with those relations, I don't know if you can actually get to a length 10, right? If you have, as soon as you start to remove certain relation types, those which are not allowed, then you have gaps, right? So
Yes.
can you even get to a length of 10?
I don't know, to be honest. I think indeed because you already restrict the relationships that are allowed, that it will be what you call uitzonderlijk if you arrive at paths that have a length longer than 10. Yes.
Right, because the shorter the paths, the more general they are. Right? That's at least my intuitive
Yeah.
sense. So the less likely it is that you have to re-estimate them, right? If you only
Yeah.
have very short paths, let's say 2 or 3 steps at most within your syntactic graph,
And then probably
then they're
general
probably very
relationships
general
that.
and they would work for other newspapers, let's say.
Yeah, for example, the modifier relationship is always an adjective with a noun. And so let's say you did that with the length of 1, and then that would probably always be correct because the adjective is right next to the noun or the aspect. So keeping it very general or quite restricted in short paths, then you should be able to do that with success without re-optimizing them. Yeah. But yeah.
Is there anything you can say with like this 1700 or something like aspects used there? So this is the extra stuff you get.
Yeah.
Is there any way to make any statement about like which aspects are important?
No, so it was quite.
Because some of these are just words.
Yeah. Yeah. And so I did take a look at the components that were made by the PCA,
Yeah.
and which aspects sort of then landed in the component that was used, for example, in IC.
Okay, but but I want it in your neural net, because that's the one you're sort of saying is the best.
Yeah.
So I would like to know then, okay, apparently I can use this method, and I need to include these sentiment variables. I don't include the other ones. But so which aspects?
No, so with the neural networks were also the components from the PCA, and
okay, yeah,
that
right. You wrote that, yeah.
gave the best performance. So I didn't look as to from the original variables what did it keep.
But the random forest ones, the original ones, were also the PCs.
Also the PCA. Everything was best when we first filtered and then applied the PCA. And I think that's because these individual aspect variables, obviously they're quite sparse. So there's not there's sometimes quarters without any observation, and also the opinions behind the score can differ.
So for all of it, and the PCA didn't give you anything.
No, it was not, because I hoped that the PCA would sort of give a category like a lot of unemployment related words or something like that, but it wasn't. It was from left to right basically. What I did see, which I found interesting, and that's actually not in the thesis, I believe, was that because we had the Findler with the, let's say, economic expressions, and we had the Google search queries, and obviously the Google search queries were more. There were more aspects from that because they were 2500 versus 1500s. But in the original variables, the aspects that came from Google was around, I believe, 80%, and then 20% from Findler. But actually, with the filtering procedure, because I thought maybe that would filter out either the Findler or the Google, but the 80-20 were still the same after filtering, approximately. So I thought that was interesting that what do you say, verhouding stay the same, or that ratio stay the same when filtering.